Welcome back. We're going to continue our discussion on titrations and buffer. We've done a few labs understanding how titrations work, and the last lab we did was primarily to reinforce the idea of what a buffer is. We're going to tie that back in. Now, titration and buffer involves a complex number of keywords that actually you need to know. You don't need to know it in depth on every one of them, but you do need to know all of them on how they go about. So here are some keywords. Think of this as like a jambalaya from New Orleans, okay? It's just complex array of ingredients. And just like that, I've pointed out just a few here. And titration and buffer is a component of a titration. Whenever you do a titration, buffer is inevitable. So there are some terms that we need to know, and I'm going to explain them as we go along with the help of me drawing some figures, all right? So there are primarily four kinds of titration. The first one is strong acid versus strong base, weak acid versus strong base, weak base versus strong acid, and finally weak acid versus weak base. Weak acid versus weak base titration, the choice number D, is very rare because there are no indicators that are available that make the endpoint or equivalence point more unique. So you would rarely encounter that titration in at least your general chemistry laboratories. The other three are very common, okay? We have done B and C. We have not done A, and there was a reason for it. We're going to probably do it this week. All right. Anyway, so while it's not a written rule or a rule that's written on the rock saying this is how it has to be done, typically the term that appears first is what goes in the flask, and term that appears second, what goes in the burette. Like for instance, on the first occasion, strong acids versus strong base, right? So the acid goes in the conical flask and the base goes in the burette, okay? So typically what goes in the flask, which is the conical flask, in this case is the acid, is known as the titrate, okay? This goes in the flask, okay? This appears second on the versus. It's like if the team that's home usually appears second and the team that appears first usually is the team that's coming in to play with the home team. It's kind of the same deal. This goes in the burette, okay? Similarly, so whatever goes in the flask is the titrate, and whatever goes in the burette is the titrant, okay? So this is the flask and this is the burette, okay? Remember, these are equipments. This is the term for it, okay? Now, there's three other things which we're going to cover immediately. Is monoprotic, means it contains, whether it's a strong acid or weak acid, it doesn't matter, or weak base or strong base. Protic typically refers to only acid, but an equivalent of it could be written for base. But monoprotic refers to one hydrogen. For example, HCl is a strong acid. HNO2 is a weak acid. HNO3 is a strong acid. HClO4 is a strong acid. It doesn't matter. They all contain one hydrogen. So they're all part of the family of monoprotic. Diprotic refers to H2SO4, one of the common ones because it's contained two hydrogen. Polyprotic refers to, I'm going to write that over here, is H3PO4, phosphoric acid. It's found in a lot of your food as a preservative. It also found in your soda, etc., as it contains three or more hydrogens fall under the category of polyprotic, okay? Now, I got this figure here. I'm going to put them all, okay? Now, titration is inevitable if you're in general chemistry or to a certain extent in other levels of chemistry, perhaps in research too. So as I've already pointed out, depending on what you define, what goes in the flask, for instance. And this is a typical pH graph, okay? Typically the y-axis is always pH, so this is the y-axis. I'm going to label this as pH 7, sorry, 7, this is 14, and 0. Okay, pH ranges from 0 to 14. And this changes. See, if you're doing an acid versus base, like in A, whatever's in the burette is what's labeled here. So if burette contains the base, okay, which is the titrant, then you write volume of base. If your burette contains the acid, as in weak base versus strong acid, then whatever's in the burette goes labeled here, because this is what you're going to add in drops. And again, in here, the pH, y-axis is always pH. Let's say this is 14, say 7, and 0. Okay? Now, there's two things I want you to pay attention to, and that's why I have both of these. Okay, so this right here, I'm going to use it for, say, we're going to do acid versus base. Okay, let's not label it as strong or weak, because the point here is I want you to understand these things. Acid versus base, so acid goes here, okay, and base goes here. So acid is your titrate, base is your titrant. Okay, you add your indicator. So because you're starting with an acid, your pH is somewhere here, and you're adding base, so your pH is going to go up. Now let's do two things here. Okay, because it's base, I'm going to do a strong acid versus a strong base. Okay, and then a weak acid versus a strong base, right? Let's see how the graphs look like. For a strong acid, strong base, there is very unique characteristics. So okay, something like this. Okay, this is not drawn to scale, but what I'm really trying to say is, we're doing strong acids versus strong base, then we're starting with acid and we're adding base. Okay, when both components are strong, okay, then what I'm also going to do is do a strong base versus strong acid. Okay, in that case, here it will be volume of acid, but we're not worried about that right now. What we are worried about is we're starting with a base and we're adding acid into it. So the inflection, it is just a mirror image reflection of it, right? So this is this one, and this is this one. Okay, you see this, the moment you see something like this that's got this really long flat portion, that should tell you both components you're using in your titrations are strong. Now pick the flattest portion, which I guess I should have really drawn over here. Okay, is really where my flattest portion is. Okay, the middle of the flattest portion, okay, if you measure like a straight line and take the half of it, which is right here, this is called the equivalence point. Now you all did that titration where the pink color stayed, right? So if you see in all of these cases, the pH is right at 7, okay? Equivalence point, and that's where the color changes. Moles of acid. What is the definition of an equivalence point? It's moles of acid equals moles of base. We're going to do a math problem to reinforce that concept, but idea here is equivalence point is moles of acid equals moles of base, right? Now, if you do the same for weak acid versus strong base, the inflection point is, which is the flat portion, is very small. The moment you see it small, then you know one of the component is weak, and if it is going this way, then your acid is weak. And when we come back here, I'm going to show the weak base just to reinforce the concept. So I'm going to redraw the graph, and then this time I'm going to use a different legend. Okay. Now, if you see that, this is kind of where I'm starting to become flat, right? And if I take half of this, which is somewhere here, which is over here, this is above 7, right? So what is important here is for strong acid versus strong base, okay, or strong base versus strong acid, okay, at equivalence point, okay, pH is always going to be 7. You don't need to do any calculation, which we will see in one of the math problems pretty soon. You don't need to do calculation. If someone asks you, hey, what's the pH of a strong acid versus strong base at equivalence point, the answer choices could be any number. The number is 7. Whereas for weak acid versus strong base, which is this, okay, for weak acid versus strong base, okay, at equivalence point, pH is greater than 7. That's very, very important. This is important from a test perspective because this is a qualitative test. No one has time to do math. So at equivalence point, pH is greater than 7. Now let's turn our attention here. If this is volume of acid, that means let's choose this, weak base versus strong acid, okay? That means we are starting with a base, okay? And then we are adding strong acid. Like I said, whatever is in the burette, so this is weak base, and this is containing the strong acid, okay? So that's why we put volume of acid. So we're starting with a base, and then we're gonna go like this. Sorry, it should be more flat. Okay, it doesn't matter. If you take the flattest portion as much as possible and take the middle portion of it, that's right there, which is less than 7. So if one of the component is weak base, another is strong acid, pH at equivalence point is less than 7. That's very, very important. This is a statement that you are making, okay? So all I want you to know is if this flat portion is really, really sharp, like here, then you look at the direction, whether it's going from 0 towards 14 or coming from 14 towards A, and that should tell you whether you're adding acid to a base or base to an acid. And the long flat portion tells you both components are strong. If the flat portion is very, very small, and then you see the inflection point, which is half of the middle flat portion, if it's below 7, so this is 7, it's below 7, right? So it must be a weak base versus strong acid. On this case, this dotted line, you see this is 7, and the inflection point is above the flat line, so that's a weak acid versus strong base, okay? And we are going to cover the buffer and this aspect of half equivalence point a little bit further in the video. This is kind of setting up the stage for what has to come. And so, you know, think of this as a titration intro 101. I have defined some of the terms and given some of the basic curves that you need to know. So when you come to lab this week, we're probably going to do A, B, and C, and then have you construct the graph and then measure a few things for me. Okay, it's going to be fun. You would like this one. So the next videos will be a little bit easier. This video may be a little bit longer, considering I've spoken a little bit longer. So, but anyways, this is kind of the information I want to give you. So stay tuned for more.